Hello everyone, I'm Hyungyu Shin. I'm a PhD student in KICS Lab at KAIST. I'm going to present our work, AlgoSolve, supporting subgoal learning in algorithmic problem solving with learner-sourced microtasks. So, what is algorithmic problem solving? On the left-hand side, we have an example of a problem. Find the sum of k largest element in an array. Then our task is to write an algorithm that solves a problem, like this. Here we have a code that returns the sum of k largest element in an array. Basically, we need to write this kind of code that solves the problem. Because of the complex nature of an algorithmic problem solving, planning is really important. What I mean by planning is basically about how to solve the problem. In our case, for example, one of the plans would be like this. First, compute k largest element in an array. Second, compute the sum of the k largest element. Then return the sum. That would be the plan. Of course, we have to think about how to exactly compute the k largest element in an array to come up with a more complete plan. Although such planning is really important, novice learners often overlook the planning. So the question is, how to help novice learners create better solution plans. Research showed that subgoal learning helps learners develop more complete solution plans. Here's an example of subgoal learning where learners receive a step-by-step information of how to solve the problem and with the subgoals as well. You can think of subgoals as a group of steps that share the same goal. So yes, it is useful, but it requires subgoals, which are often created by experts. In summary, subgoal learning requires high-quality resources made by experts, which are scarce because of high cost of production. How can we collect high-quality resources in a scalable and organic way? As a solution, we present AlgoSolve, a learner sourcing system for scalable subgoal learning. Learner sourcing is a form of crowdsourcing where learners collectively contribute novel content for future learners while engaging in a meaningful learning experience. The goal of AlgoSolve is to collect, determine, and provide high-quality subgoal labels so that learners can enjoy a meaningful subgoal learning experiences. It is important to note that we have two stakeholders, learners and the system, where their goals are different. Learners want to have meaningful subgoal learning experiences. The system wants to collect high-quality subgoal labels. And the key is how to design a learner sourcing workflow that allows both parties to achieve their own goals while interacting with each other. And here's our overall pipeline of AlgoSolve. It consists of two stages, and each stage contains a set of tasks. The first task is a subgoal voting task, where the system asks learners to vote for the most high-quality subgoal label. The second task is a subgoal labeling task, where the system asks learners to create subgoal labels. During these two tasks, learners can enjoy meaningful subgoal learning experiences by receiving high-quality subgoal labels from the system. The system can identify high-quality subgoal labels from learners using multi-dueling bandit algorithm. Let's see more detailed walkthrough. The first task is a subgoal voting task. The system chooses a snippet of code and gives 5 different options. 3 of them are considered as high quality, and 2 of them are randomly selected, which are considered as relatively low quality examples. We intentionally included such low quality examples so that learners can easily contrast high quality and low quality examples, which can be useful for understanding what makes high quality subgoal labels. Since it is a learning process, it is important to provide feedback to learners. Once learners vote for an option and click Submit button, the system presents how other learners have voted for each item as feedback. With this voting result, learners can get a sense of whether the option that they have chosen can be of high quality or not. The next task is a subgoal labeling task. The system chooses a snippet of code and asks learners to create a subgoal label for that snippet. Here as well, the system provides feedback. Once learners submit their subgoal label, the system presents 3 high-quality subgoal labels. Learners can revise their submission after reading the feedback, and the revised submission is going to be stored in the system. In this process, learners can reflect their own understanding of the subgoal labels by making such comparison. So far, we have covered 2 tasks. Now the system collects 2 types of data, compares the result, and subgoal labels. With these 2 types of data, how can the system identify high-quality subgoal labels? We can formulate this problem as multi-dueling bandit problem. Let's consider this case. The system needs to present high-quality subgoal labels for providing meaningful subgoal learning experiences, like this one. The system also needs to expose some subgoal labels that require learner feedback to identify high-quality subgoal labels, like this one. Former one is called exploitation, and the latter one is called exploration. Multi-dueling bandit algorithm basically make a balance between these two so that the system can successfully identify high-quality subgoal labels while providing meaningful subgoal learning experiences. In summary, with our pipeline, learners can enjoy meaningful subgoal learning experiences with high-quality subgoal labels provided by the system, and the system can collect high-quality subgoal labels from learners using multi-dueling bandit algorithm. To evaluate AlgoSolve, we conducted a between-subject study where the baseline condition asks learners to create subgoal labels and read expert label, which is known to be the best subgoal learning strategy. AlgoSolve condition asks learners to use AlgoSolve to create subgoal labels. The first research question is, can AlgoSolve provide high-quality subgoal label examples? To answer this question, we asked experts to rate the quality of subgoals stored in the system. It turns out that raters equally preferred the system labels and the expert labels, which means AlgoSolve can identify high-quality subgoal labels. They noted that expert-created labels better describe the high level and abstract purpose of the subgoals, and the system-selected labels provide more details for understanding the given code, such as descriptions like, in the worst case as n, for the two patterns of ordering. The second question is, can AlgoSolve help learners create better quality subgoal labels? To answer this question, we compared the quality of subgoal labels between the baseline and the AlgoSolve. It turns out that AlgoSolve helped learners create better correlated labels. This graph shows an overall quality of subgoal labels between the baseline and AlgoSolve, where the y-axis represents the proportion of the subgoal labels, and the color represents the quality of subgoal labels. Here, L3 is of high quality, and L0 is of low quality. As you can see here, AlgoSolve was able to collect more high-quality subgoal labels. Here are some interesting discussion items. First, how to seamlessly connect the solution plan with its actual implementation. We specifically focused on planning phase, but implementation is another huge task in algorithmic problem solving. Can we also seamlessly support such implementation stage as well? Second, can we reuse subgoal labels to other problems? We focused on collecting subgoal labels for a single problem, but benefits of subgoal labels are that they can be reused to other kinds of problems. Designing a learner sourcing workflow for reusing the subgoal labels to other problems might be an interesting direction. Third, can we generalize our approach to other problem-solving contexts, such as mathematical problem solving? We believe it should be yes, but a learner sourcing workflow should probably be tailored to a specific problem-solving context. Thank you for listening, and don't forget to check out our project website, algosolve.kixlab.org. It contains more details and our contact information. Thank you.